Welcome back to our second day of our scientific notation unit, and today we're going to actually take a little step back from scientific notation after last time we talked about just converting back and forth and something you might have seen in the past. But we're going to today just take a look at exponents in particular and all of the things that happen when you do operations with exponents. So today's topic is called properties of exponents. Your learning target is I can perform basic operations, so that would be adding, subtracting, multiplying, dividing, on monomials containing exponents. Alright, so covering up some of this so you can't see it. And we start with laws. So there's three laws we're going to talk about today of exponents, and the first one is multiplying. It says when multiplying powers of the same base, keep the base and add the exponents. So let's see an example of what that would look like. Here's one. So we get 5 squared times 5 to the third. And this is probably one of the last times you'll see that x for times. It normally would be written like this, with a dot, or like this, with parentheses. But either way, they're all the same. So if we apply the rule, it says they have the same base, so the 5 is considered the base at this point because that is what the exponent is attached to. So if we were to make a little map of what all these things are called, this would be the base, this would be the exponent, and then this right here would be the coefficient. I guess I could have just wrote it all out to the left, but so in this case, the 5 is the base. So we're going to keep that base. We're going to say 5 as a base, but add the exponents. So I have a 2 and a 3 for my exponents. So I'm going to add them together and I get 5. So you might be asking, why? Why is that the rule? Well, it's because if I were to expand this out and write it in expanded form, 5 squared is the same as 5 times 5. And I'm multiplying this by 5 to the third. So that dot is just the dot in the middle. And then that means there's 5 of those being multiplied together. In the end, all I have is 5 5s being multiplied together, and that's 5 to the 5th. So rather than write this out every time, we have a method of just adding up the exponents and doing it that way. So let's try some examples a little faster now. Here's a bunch. We have number 1, 8 is our base. So it's a good idea to kind of say that in our head, 8 is the base. So we keep it, and then we add 2 and negative 5. So it's almost like a little math problem in the exponent area. That would be negative 3. Right. Number 2, 4 is our base, so we keep that. And we're adding 5 and negative 5, and that's actually 0. And we'll talk about what a 0 exponent means soon. Number 3, 9 is our base this time. And our exponents are negative 3 and negative 2. So add that together, get negative 5. So it's a pretty simple concept. Up here, sometimes people are fooled by this because the first 5 doesn't have an exponent, but it really does. It's an invisible 1. When people get this wrong, I'll ask them, how many 5s are right here? And they'll tell me 1, and I say, yep. But usually they think of it as nothing because they get stuck on adding 3 and there's nothing there. But there really is, it's a 1. So this is 5 to the 4th. Alright, this time I have a base that is a variable, so I keep that variable base, and I add 6 and negative 1, and I get 5. And then number 6, keep the n, and I get negative 8 when I add it together. Alright, here's a few more. We're not going to do every single one of these, so don't start copying right now. Just do the ones that I do. I'm going to skip ahead to number 9, because number 9 has those numbers out front, which we call coefficients. And the law didn't say anything about coefficients. And the only reason it didn't say it is because there's nothing different you do. You just multiply them, just like the problem says. So we're going to multiply 8 and negative 3. We get negative 24, and then we just follow the rules for the rest of it. We keep the base, which is the r, and we add the exponents. 4 and 2 is 6. All right, practice on 10 again. Multiply our coefficients. We get 12, positive 12 this time. And remember the invisible one here and the invisible one here before we start adding. And I get x to the third and y to the third. All right, I'm going to skip the rest here and move on to law 2, which is dividing. So when you divide, it's actually basically the opposite of multiplying. It says when dividing powers of the same base, keep the base just like before, but this time you subtract the exponents rather than multiply them. So this is different right here. And this time they actually do mention the coefficients. It just says if there are coefficients, you divide them. All right, so we look at number 1, and we have to be careful because 4 is not a coefficient. 4, in this case, in both the top and the bottom, is a base. So that is the thing we keep, and the exponents we subtract. So that gets tricky for people because a lot of times we'll see that as variables every time, and then all of a sudden I throw numbers in as a base, and people want to divide them, but we don't actually divide them. So 5 divided, I was going to say it again. 5 is the base, so we keep the base. I got stuck on saying what you shouldn't do, and I almost did it. Keep the base. And then 3 minus 4, you always have to do the top one minus the bottom one, not just whatever order feels better. And 3 minus 4 is negative 1. And then 3, 4 is the base again. And you got to be really careful with these negatives when you're subtracting. So off to the side, I like to say negative 2 minus 3. And now I know that that is negative 5. If you need a calculator just to make sure you did it right, that's fine. And number 4, this time it has a variable base, which I keep. And then 5 minus 8 is negative 3. We're going to dive right into, if you notice that it went from 4 to 13 or something. I skipped a bunch of the problems that were very similar, and these ones are a little trickier. So the first one, notice a is the base, and I know that because that's what the exponent is attached to. So that means this 3 and this 24, they're coefficients. And the law said, squeeze it in there. The law said we had to divide those. So 24 divided by 3, that gives me 8. And then I keep the base, and then I subtract the exponents, and I get 3. So that's what you do when there's coefficients. You just divide those. So in 14, negative 27 divided by 9 is negative 3. Keep the x base. Now this time there's 2 variables, so I think of them separately. So I'm going to snake this line through here, and I'm going to do the x's first. Keep the x and do 3 minus the invisible 1 on that x, and that gives me 2. Now this is interesting. If I keep the base and I subtract the exponents on y's, I get 0. But a better way to write this is 3x squared, and that's it. So you can think of this part right here as just completely canceling out. Y squared goes into y squared once, and that 1 doesn't change anything. And that's shown at a very extreme level on number 15. They're the exact same thing on the top and on the bottom. I could go through all the rules, like 5 divided by 5 is 1. M, keep the base, subtract the exponent 0. Keep the base of n, subtract the 1 minus 1 is 0. That's a lot of writing for something that really just equals 1. Because these cancel, and the 5's cancel, but it all cancels to 1, not 0, 1. And 16, we'll finish this one up with 15 divided by 5 equals 3. There's an x still on top. That canceled with nothing on the bottom. If you notice that there's no x's down here at all. So the x just kind of stays the same. And then 4 minus 3 is 1. And you don't have to write the little 1 on the y. It looks a little more professional if you just leave it y. Alright, and this is the last law for this video, and it is a power of a power, we call it. And unfortunately, this is the one that's usually the trickiest. It tricks people the most. So it says power of a power. Multiply the exponents. So if there's exponents on the outside, you multiply them with whatever exponents on the inside of parentheses and apply the exponent to the coefficient. So that's a little bit more vague of what we're doing here. If we follow the rule, it says to apply the exponent to the coefficient. In this case, 9 is a coefficient on the inside. X is a base, and it has an exponent of 1. So if I do 9 to the third, that would be 9 times 9 is 81, and 9 times 81 is 729. So you get 729 there because it's 9 to the third power. And then it says to multiply the exponent. So that's 3 times 1. So you just get x to the third. So this is another why does this work thing. So if you have 9x, all of that to the third power, what you're really saying is 9x times 9x times 9x. And if we apply the multiplication rules, that's 9 times 9 times 9. And that's where the 729 comes from. And then, because we're multiplying, you add up all 3 of these exponents. And since they're all 1, you get a grand total of 3. And that's why it works. But this is the quick way of doing it. This is the longer way of doing it. And they both are fine. Alright, and this one is a little more confusing because 3 is the base. It is not a coefficient. So we will not be doing 3 to the third. We keep the 3 and just multiply the exponents. 3 times 2 is 6. And again, that works because 3 squared times 3 squared times 3 squared, you keep the base and add up all of these. So it's really important to know which is the base, which is a coefficient. Alright, we'll try a few more here. X is our base this time, and multiply we get 6. That one's really, really short. Number 2, this time the 3 is a coefficient because the exponent's not attached to that, it's attached to the x, which is the base. So this 2 affects the 3 by raising it to the second power. So it's 3 to the second power, which is, oops, well, I don't want an equal sign yet. That would be 9. And then I multiply exponents. And that gives me x to the 6. Alright, up at 3, there's a lot of stuff going on here. Negative 2 is the coefficient. So it's going to be negative 2. And I have to be really careful because it's all of negative 2. I don't want to leave that negative behind. And some people use the calculator. And the calculator doesn't know that you mean all of negative 2 to the third power. It's different than saying this. It ignores the negative first and then just does 2 to the third and then puts the negative on. But we don't want that. We want negative 2 times negative 2 times negative 2, which is a negative 8. So I know it starts with negative 8 because that's negative 2 to the third power. And then individually, it's almost like distributing. I multiply 3 and 2 for the x's, and then I multiply 3 and 3 for the y's. Alright, and last one, back to a slightly easier one here. 2 is the base, so I keep it. And I multiply negative 3 and 2, which is negative 6. Alright, I'm going to leave you with one challenge. We'll call this a challenge problem. So I want you to divide this one. It's division one, but there's also power of a power involved in it. So you're going to have to go back and see if you can do power of a power first. You really want to do that first, and then divide second. And that's what I'll be looking for when you come in with your notes. I tried to keep this under 15 minutes. It looks like I did it. And good luck, and we'll see you on the other side.